Okay, good morning. As I mentioned earlier, there is one section in this chapter related to probability. I have skipped that one for the time being. Let us continue with the application. This is probably more natural continuation after calculating the areas. Might be it's more reasonable to start calculating the volumes. And then of course we go back and see that how can integrals help us to calculate probabilities as well. But for the time being, let us concentrate here. So the fundamental problem here is this. You have a curve. Let us for the time being consider that I have a curve in the interval that I am interested in. Let us assume that the curve is above the x-axis, and that this is the graph of the function f of x between 2 points A and B. So here we learned how to calculate this area before. Yeah, so that was here in this case, the area was the integral from A to B f of x dx. Now today we want to learn that if I start rotating this area about the x-axis, you need to have a little bit of good imagination because drawing these things with whiteboard pen is probably not that easy. But you can imagine if I take this area and rotate it about the x-axis, it will generate a three-dimensional shape, yes? The goal is to calculate the area of that generated shape. So that is usually called volume of revolution, yes? So here revolution means rotation, yes? So the solid object that I get, the volume of that is called the volume of revolution. I'm rotating this curve about the x-axis. Okay, and of course you know the trick is as before. So it means that you need to imagine that shape and then try to slice it into very thin parts, calculate the volume this time of each one of those slices and then add them up. And then of course make the subdivisions infinitely big so that this becomes precise. So that's the idea, yes? Okay, so let us concentrate here. Before doing that, I want to make sure that you remember the formula for the volume of a cylinder, yes? So if you have a cylinder, so that its radius is r and its height is, say, h, the volume of this cylinder is pi r squared h. So do you remember the fundamental area that we started with to calculate, to determine that formula was the area of the rectangle. So we take this as a starting point, and here we want to take the volume of a cylinder as a starting point. Okay, why this cylinder comes into the game is not that hard to see. So what I do, I start doing the same thing. So I start partitioning this interval to, for example, n equal pieces. So let us concentrate on one of the pieces. For example, the kth interval, as we had before. Of course, I exaggerated a little bit so that you can see that. For example, this becomes x node, the 0, 1, and this becomes the last one, xn, and then I have some partitions in the middle. Let us concentrate on the kth interval. So if I go here, I want you to imagine when I rotate this about the x-axis, only this part, if you imagine, it does not generate exactly a cylinder, yes? Because this part is curved. I hope that you can imagine what is the shape, what the shape looks like. Not exactly, but you can imagine what is happening. But that is not exactly a cylinder, yes? Because at least this part is curved. So if it might be better if I draw this cylinder in this direction. Because in principle we need to think about imagine these horizontal cylinders when you generate. Of course, they're also very narrow usually. So something like this is a better imagination, yes? Yeah, let me make it better for you. So something like this. It's a better imagination for this. Okay, so the point is that if I take this rectangle up to here, not the whole area, this definitely generates a cylinder, this rectangle only. And of course, this should also be taken into account, but we cannot do that unless I make this smaller and smaller. This error becomes smaller and smaller, and then in the limit that I have infinitely many points, then hopefully you agree with me for the same reason that error approaches zero. And then we can trust with that. So if I ask you, can you calculate the volume of this cylinder, ignoring this momentarily, let us assume that I want to rotate this. First of all, can you imagine that if I rotate this about the x-axis, it really generates a cylinder? Yes or no? Okay. Now, can you tell me what is the volume of that cylinder? I need to write a pi, and then you need to tell me what is playing the role of the radius of that thin cylinder. Yes?
F of xk or xk minus
1. F of xk minus 1. Yes, because this, I hope that you agree that this will play the role of the radius of that cylinder. And that is f of xk minus 1 totally to power 2 multiplied by the height. What will play the role of the height? What is the height? You agree with me that this would be the height, yes? And this is what? This is delta x. Do you remember? The difference between these, the length of each subinterval will be denoted by delta x. So this becomes delta x. So if someone asks you what you have written on the board so far, I would tell that this is the exact value of the cylinder generated by this rectangle, but it is not exactly the volume that I want because I am ignoring the volume generated by this part. Yes? So I can say that the volume that I am looking for is approximately this. The volume of this part for the kth part. So the volume generated by this part on the kth interval is approximately this value. And I want to find the total volume, so I have to do the same thing for the next interval, for the next interval, for the other intervals, and then add them up. Yes? So hopefully you agree with me that the volume that I am looking for is approximately the sum of these volumes where k goes from 1 to n. Yes? Is that understandable? But from here to here, this is exactly, this is also approximately equal to the sigma, k goes from 1 to n. Instead of v of k, I put this. Yes? But if I ask you, how can I find the exact value for the volume? Hopefully you say that the exact value will be the limit of this expression when the number of partition goes to infinity. I'm just making this plausible for you. Yes? Is that understandable? So the volume that we are looking for seems plausible to have this the candidate for that volume. Is it clear so far or not? The process, I want you to understand the process, because just memorizing the formula is not very helpful. Any questions here? Okay, but do you remember what was the definition of an integral? Let me write it here. If you remember, we already talked about the definition of an integral. So forget about this for the time being. Let us review what we learned about the definition of this integral. So an integral is defined to be the limit. So if you don't mind, let me change the name of the function here to something else. Don't get confused here. So let me write g of x. The integral of g of x dx is the limit of the sigma g. Do you remember I wrote alpha k, and then I wrote delta x, and then k goes from 1 to n, then I send n to infinity, and if you ask me what is alpha k, I would say that alpha k is a number within the kth interval, and delta x is just this left. So do you remember that was the definition of the integral of g(x)? Now compare this one with the one that we have, because my goal is to write this limit as an integral. So first of all, what I want you to understand, this pi is a constant number. All terms contain a pi, so in the sum I can factor pi out. And then again pi is constant and it is independent of n, so in the limit doesn't play any role, I can pull it out. Yes, so hopefully you agree with me that I can pull pi out, and then I can write the limit of sigma of f of xk minus 1 squared delta x, and then k goes from 1 to n goes to infinity, yes? Now can you tell me, how can I write this as an integral? Is it possible to write this as an integral? Compare this limit with this limit. So I have limit n to infinity there, I have sigma k goes from 1 to n, I have delta x there. So this part apparently is playing the role of g of x. Yes? Is that clear? So because this limit becomes the integral from a to b g of x, can you tell me what will happen then here? This becomes equal to pi. This is pi. What can I write for this limit if I want to write it in terms of integrals? Because xk minus 1 is a number within that interval. Any number can, alpha k is an arbitrary number in the kth interval. So here, xk minus 1 is taking the role of alpha k. Doesn't matter. But what can I write for this integral now? This becomes what? This becomes an integral. Okay, can you fill up the gaps? What are the limits? What should I write here and there? Is it understandable or not? Yes or no? What should I write in front? Yes?
From A to B.
From A to B, that's the same interval. And then dx. Then I'm waiting for you to fill up this gap. What is that? It should be g of x. Yes? Yeah, instead of alpha k, I put x, I write g of x. This is playing the role of your g of alpha k. Yes? So then it becomes this function. Let me write it down, okay? Okay, so it becomes f of x squared. Yes? Yes or no? Because this is playing the role of g of x. Whatever you see here, you instead of alpha k that appears, you put x and then repeat the g here. I am doing the same thing. Whatever appears here, playing the role of alpha k, I write it x and then I write f. But this has power 2, I put power 2. Is that understandable or not? Yes or no? Okay. So that is the formula you will get in the formula sheet. But this is, I want to understand where this formula is coming from. It is reasonable. So if someone asks you where this formula is coming from, you would say that I partition the area into n pieces, and then I start approximating the real volume with the volume of cylinders, and then I add the volume of the cylinders. It becomes an approximate value to the volume. then I make the number of partitions infinitely large so that my error approaches 0. And that number becomes this. Yes? But because of the definition of the integral, do you remember I told you that this limit appears in many places? So let us give it a name and study its properties. And this is another property, this is another part that this happens. So if you want to understand that, you can call g of x equals to f of x to the power of 2. Yes? And then instead of this one, you can write g of xk minus 1. But the limit of sigma of g of xk minus 1, according to the definition, is the integral, so this becomes this integral. So anyway, this volume is this. So you see, there are some differences that you need to imagine. There is a pi, which in the limit for the area we don't have that pi, and then of course I have my function squared, but for the area I have the function itself. Yes? Okay. Let us use the formula to calculate some volumes. Okay. There are different types of problems. We can categorize them into two. So they give you a curve and they ask you, okay, if I rotate it, it becomes a solid object. Find the area, volume of that solid object. For example, let us make it very, very simple. I take this function, y equals to square root of x, and then I am interested up to 4. I take this area, I rotate it about the x-axis. You might imagine what will happen. You can imagine in your head what would be that volume. You want to find the area volume, the volume of that object, of that solid object. So what should I do? According to the formula, I write v equals to pi integral. Here it is from 0 to 4. And then I have to write square root of x, but not the function itself. I have to square it, and then dx. And then I have to calculate this very simple integral. So before starting the integral, square root of x squared becomes x dx. But this is very simple. So this becomes pi. The primitive function for x is x squared divided by 2. We should run it from 0 to 4. Okay, and then I put 4, I put 0, and subtract them. So this becomes how much? If I put 4, 16 divided by 2 is 8, so it becomes 8 pi. If I plug 0, it becomes 0, so it becomes 8 pi volume units. So the volume that is generated by this object is 8 pi volume units. Is that clear? Okay. But of course, this is not very interesting. Let us try to see how we can use this method to find the formulas for the volumes that are famous. For example, let us consider how we can use this to find the volume of a cone, for example. Yes? Any questions here? Okay. So for example, let me give you a cone like this. And then I give you the radius and I give you the height. And I ask you to calculate the volume of this object. Yes? How we can do that? This is it seems a little bit irrelevant, yes? Because for using that method, I need to have a function and then draw the graph of the function and then find the area between that function and the x-axis and then rotate it. Then I can calculate the volume of that generated object, yes? But here I do not have that function. I have a solid object from the beginning. I want to use this trick or this method to find the volume of that object. Do you have any proposal? Yes?
I think they're quite related because the formula for the volume for this one is the base times the height divided by 3. So it's a difference with a product, 1 divided by 3.
Yes, but how we can come up to that number? That's the point. We want to prove it. So the only thing that so if you want, you can say that, okay, I consider the volume of revolution as an axiom. So I accept that this would be the volume of a cylinder. Yes, I will accept that this is the volume of a cylinder, that formula. But from now on, I want to prove exact values for the volumes of other objects. Yes. So how can I do that? I mean that how can you find the connection? So you need to imagine a function so that after being rotated about the x-axis, for example, it generates the cone. Yes? Can you tell me what function is good for this? If you want to generate a cone, yes?
Almost any straight line function.
Any straight line, yes? But we want to we have to adapt this straight line. So okay, so what we do, we take the coordinate axis here. You see this problem is this one only. We want to make the picture somehow that I can use this method. So I would say that if I take this line, for example, and rotate it about the x-axis, definitely it will generate a cone for you. Yes, this is clear, hopefully, yes? Agree with me? But I want to generate exactly this cone. Exactly this cone means that I want to make sure that the radius of the cone generated is exactly this r given, and the height of the cone generated is exactly this h given. Okay? So I hope that you agree with me. This angle plays a role, because if this angle is too narrow, then the radius becomes very small, and if this is very wide, the radius becomes larger than this one. So I have to fine-tune this angle so that it exactly generates my cone. Yes? How can I do that? Is that understandable what I'm going to do? Because, of course, if I just rotate any straight line about the x-axis, it will generate a cone for me, yes? Yes, it will generate a cone. But I want to do some adjustments so that the cone generated is exactly this cone. But of course it is clear that if I rotate this cone, the volume will not change, yes? So that's the point. So how can I adjust that? Okay, can you tell me, how should I adjust this? Because, by the way, let me tell you something, because you need a function. What is your function? You need to write y equals to something. This line is passing through the origin, so if I write the k form of that, it is kx plus m. But what is the y-intercept? The y-intercept is 0, so this becomes y equals to kx. So this line is kx, but still if I ask you what k is, it is missing. You need to be able to write k in terms of h and r. Yes, because I want to have a function so that when it is rotated about the x-axis, it generates this cone. We realize that that should be a straight line passing through the origin, but I cannot take any straight line. I have to fine-tune this k so that when I rotate it, it exactly generates this cone. Okay, can you tell me what k should be? K should be a number in terms of r and h. What that number is? Okay, let me ask the simpler question first. I go from 0 for generating this cone up to which point on the x-axis? That is clear. Up to which point?
H.
H. Yes, that's clear because that will play the role of height. So this I have to, for example, this is my h. From 0 to h. And then I want to have this equals to what? R. So this means that this alpha, tangent of alpha, is equal to the opposite side divided by h. But do you know, I told you several times, what is tangent alpha? Tangent alpha is exactly the slope. Is that right or not? So remember this if you have forgotten. That is important to know. If you have a straight line, the tangent of the angle that line makes with the x-axis is the slope of the line. So this means that I found this. The slope of the line is r over h. And then it means that the line that I was looking for is r over hx. Okay, now that you have it in final form, let me explain it simpler for you. So you know that what is your goal? Your goal is to generate a cone with these dimensions. So it means that when you reach to h, this should be r. And that is clear. If I, instead of x, I put h and h will be cancelled, y becomes r. That's exactly that number. So you could guess that function. Now that everything is ready, I can calculate the the volume of revolution of this area. So what happens? The volume becomes pi, according to the formula, integral from 0 to h, but my function squared. So r over hx squared and then dx. So if I manage to calculate this integral iota, okay, calculating the integral is simple, but I want to wait for you. Is there any questions up to here? I want you to understand why if I calculate this integral, it gives me the volume of this cone. Yes? Yeah? Is that understandable? Okay, so let us calculate. So this becomes pi integral from 0 to h. This squared becomes r squared, h squared, x squared dx. Okay, but r and h are constants. So that is a multiplicative constant. So I don't need to worry about that. I just find a primitive function for x squared. So I have a pi, I have r squared over h squared, and then instead of x squared, a primitive function is x cubed divided by 3, but I have to run the integral from 0. So I have to run this expression from 0 to h. What does it mean? It means that I replace x with h, replace x with 0, subtract these values. Okay, if I replace x with h, it becomes pi r squared over h squared. Then I will have h to the power of 3 divided by 3. And then if I plug 0, everything vanishes, so I don't need to write. If you want, I can write minus 0. But this h to the power of 3 and h to the power of 2 cancel each other. Only one h is left. And I have 1 over 3 here. So let me write it clean here like that. 1/3 pi r squared h. And that is the famous formula for the volume of a cone. 1/3 of pi r squared h. Yes? Any questions? Okay, let us do another thing. For example, let us try to find the volume of a sphere. Okay, so how do you do that? I want you to think about it to tell me what to do. So now you understand. For example, let me just draw a sphere for you here. Okay, so something like this. If I want to find the volume of a sphere, I give you R, and I ask you what is the volume. So I give you R, and you're supposed to find the volume of this object. What are the steps that you need to think? This method that we learned here doesn't work like this. You need to imagine a curve so that after being rotated about the x-axis, it generates this sphere. And then using this trick, you can find the volume. That is the way that you have to think. And it is not hard. What is the curve that if being rotated above the x-axis, it generates this? Yes? Yes, what's that?
Sine of x.
No. Be careful. Sine of x generates something might be similar to a sphere, but hopefully you agree with me that is not the exact sphere. What is that one? It's not hard, yes? Just see. I don't know if you agree with me, if I start rotating this blue part around this dotted line, it will generate the whole sphere. So what is this one now? That is a semicircle. Yes, a semicircle with the same radius. Understandable or not, Nabil?
X squared.
No. Do you understand if I rotate a semicircle, it will generate? Then we will adjust this, of course. I want you to find at least the curve correctly. So the curve is not sine function. Yes, it should be a semicircle. So, but what semicircle? Of course, it is always clear. You see, first of all, I can have this semicircle. But this semicircle is not easy because I am making life harder for me. Try to make it as simple as possible because the equation of a semicircle starting here is harder than the equation of the semicircle that started with the center at the origin. So that one is easier. It doesn't mean that if you want to make life harder for you, it is not possible. You can start with that one, but that is not good. So I would say that I myself prefer to draw a semicircle here. I hope that you agree with me, at least, that if I rotate this area below this sphere, below this semicircle, above the x-axis, it will generate a sphere. But what should be this number and that number so that it exactly generates this sphere with radius given r? What should be this number here and that number here? This number at least, what is this number? This should be r, the same r, and then of course this becomes minus r. Okay? I don't know, do you remember what is the formula for this curve? We discussed that before more or less, if you remember. What is that? Yes?
2 pi r divided by 2, so pi r.
No, what is the equation for the function? Because you need a function, I want you to understand what is going on. First, you need to have a function because you want to put it here, yes? If you want to use this formula to calculate the volume, first of all, you need to have some imagination to see what curve, when rotated, generates this volume. But this is not enough. After making these adjustments, you need to find an equation for this curve. Yes, as we did here. You see, we found an equation for this curve. Of course, here the curve is the straight line. And then I am allowed to use this. I will be able to use this formula by plugging it in. So you need to know an equation for the semicircle. So what is that? Do you remember we discussed a lot about this? But this is very common that you forget easily, yes? Yeah. So what is an equation for this curve? For example, as you said, if I draw this and I say this might be, you say this is the sine function, so the curve is y equals to sine. Now I am asking more or less a similar question. This curve has an equation. Of course, y equals to sine x is not an equation for this curve. So what is an equation for the curve? So do you remember we discussed about the distance formula a lot, yes? So if I take a point on this curve, the distance from that point to the origin is again equals to the radius. But what is the distance formula to the origin? It is the square root of x squared plus y squared is equal to r. But I am looking for y, so I square it, it becomes r squared. And then I am looking for y squared, so it becomes r squared minus x squared. Then y becomes plus or minus the square root of r squared minus x squared. Yes? But this minus sign is not acceptable here because this semicircle lies above the x-axis. Above the x-axis, y is always positive. So that is why we ignore this negative sign. So this doesn't. So that is the equation that you are looking for. So y is equal to square root of r squared minus x squared. Yes, is that understandable? So I want you to understand the steps. I give you a solid object with given dimensions. For example, here in this case, we have a sphere with given radius r. Assume that r is given. Then you want to find the volume of this object. The first thing that you need to do is to imagine a curve independent of the coordinate system, just a two-dimensional object, so that after being rotated somehow, generates this object. I hope that you agree with me. It was not hard to guess that this is the semicircle. If I rotate the semicircle around its diameter, it will generate a sphere. Then you start a coordinate system and try to make life easier for you. I would recommend you to take this one to generate a sphere rather than this one, because the equation for this one is not that simple. The equation of this curve becomes a little bit hard. Yes? So after these adjustments, you need to find the equation of your curve finally. That is inevitable, because I need to plug the function here so that I can find the volume. Okay, for this case, I used this trick, so I was able to find this equation. Now, eventually, let us calculate the volume. So what we do, we calculate the volume using this. So it becomes pi integral. Okay, you fill up the gaps, yes? You have the formula on the tape, on the board. So what should I write? The lower limit is minus r. What is the upper limit? R. And then what should I put here? I will also have the x here, but what should I put here? Is not the function, is the function to the power of 2. Even better. Yes? So when I raise it, so let me write everything in detail. Yes, is that understandable? So if I can calculate this integral, then this becomes the volume of this sphere. But this is very easy, because the hard part is a square root, but this power of 2 will actually kills that square root. This is why if I want to find the area, this is beyond the high school. Yes, but volume is in the limits of the high school. Yes, because when I want to calculate the area of this, I don't have this power of 2. Yes, then I have to deal with the square root of r squared minus x squared. So I have to learn how to find the primitive function for that, but you have to wait for the university to know that. This is why in the high school level, finding the area of a circle is harder than finding the volume of a sphere, because this power of 2 kills this square root sign. Yes, so then what happens? This becomes pi integral from minus r to r, and then I have r squared minus x squared dx. Okay. Of course, I don't know how many of you have the formula in your mind. What is the answer? Do you know? What is the answer that you're supposed to get at the end by the calculation? Do you remember the volume of a sphere? Yes?
4 pi r cubed divided by 3.
Yes, so 4 over 3 pi r3. Okay? Now I want to pause recording the video and I give you time to calculate this integral to see if you really get this number out or not. If you get that one, it means that your calculation is right. Otherwise, there should be an error somewhere. So I want to give you 5 minutes to calculate this integral yourself. Yeah, so the people at home, when I pause the video, recording the video, you will not be able to see the board. So if you're interested to continue, please take notes from this last integral so that you can work on it yourself. Okay? Okay, so did you get the correct answer? Yes? Okay, so tell me what to do. I want to find a primitive function for this function. Okay, let me ask you to see if you understood it correctly. So pi is just a pi. But what is a primitive function for r squared? What is that?
R squared times x.
r squared times x. I hope that everyone agrees. Do not write r cubed divided by 3, yes, because r is a constant. The primitive function for r squared is r squared x. And a primitive function for x squared, then I don't need to ask, I know that you know this. So I hope that you didn't make any mistakes here. And then it goes from minus r to r. Yes? What I have to do, I have to be careful not to mess up the minus signs, yes? Otherwise you will get 0, which is of course nonsense, yes? So this becomes pi. And so let me write it in two branches. So you put r there, so it becomes pi r squared r minus r cubed over 3. So if you simplify that, it becomes r cubed minus r cubed divided by 3. So this becomes 2/3 of pi r cubed. Yes? That's the answer that you get from the first one. If I plug minus r there, it becomes pi r squared times minus r minus r to power 3 divided by 3. So then it becomes pi, this becomes minus r cubed, this becomes minus, but this becomes positive. And then this becomes negative 2/3 pi r cubed, yes? Then I go back to horizontal, I have to write the number above minus the number below. Yes? And then, of course, as you predicted, the answer becomes 2/3 pi r cubed plus 2/3 pi r cubed. So this becomes 4/3 pi r cubed. Yes, and that is exactly what we got. But I myself, because you see that I have to calculate and I have to be careful, if I calculate the area from 0 to r, so if I go from 0 to r, it is also possible, yes, and it is better. If I go from 0 to r, I will not generate the sphere, I will generate the hemisphere. But then I multiply at the end by 2, it becomes the volume. The benefit of doing that is because if I go from 0 to r, then this becomes 0 to r. I really don't need to be worried about 0 part. It becomes 0, and then I calculate this one, and then multiply it by 2, and I will get the same answer. So it depends to you which one you prefer. Do you want to go from minus r to r? If you do that, you exactly get the volume. If you go from 0 to r, you do not get the sphere, you get the hemisphere after rotating it. And then you have to multiply it by 2. Yes, is that clear? Okay. Now, there are some points that it's good to know. The way that I derive the formula sometimes matters. So for example, what do you think about this scenario? I give you a function. Okay, so assume that this is my function. Y equals to f of x. For the time being, let us take things make simple. Instead of rotating about the x-axis, I want to rotate about another horizontal line. But for example, this is y equals to k. And then for example, this is A, this is B. Yes? Yes. I think I can ask a more general question. What do you think if I want to rotate the volume between two curves about the x-axis? So for example, I have this function, y equals to f of x. For example, I'm just making things simple. And then this is your g of x. Yes, y equals to g of x. And then you have it from A to B. But you are interested to rotate this area about the x-axis. It will generate some solid object with a hollow inside, yes? Can you imagine that or not? Yes. Okay, so now you want to find the volume of that object. Do you remember? If I ask you what is the area, you in principle should be able to answer my question. What is the area here? Do you remember? If I want to find the area between two functions, I have to write this formula. area that is wanted here is the integral from a to b dx. Do you remember what is this gap here? What should I write here? Yes?
f of x minus g of x.
Minus g of x. Okay? Now the question is that, this is correct. Now I rotate this area about the x-axis. I want to find the volume for that. So I want you to help me to write a formula here for the volume, and I want you to understand why this works. So how should I do that? Yes?
The volume of the upper function minus the volume of the lower.
Is that understandable? So you can momentarily ignore this, you rotate this one, you get a bigger object. That volume is the volume of the total area rotated about the axis. You are not interested in that part. You also calculate the area here and then subtract it. Okay, can you imagine if you do all those things, what can I write for the formula then? So let me calculate. As you said, the volume is the volume of the one above, so which is pi integral from a to b f of x squared dx. This is the volume corresponding to the function f of x. Minus the area for g of x. This becomes the same integral, but instead of f of x, I will have g of x. That would be the formula. Yes? But let us combine them into one single formula. I factor a pi out, and then this becomes integral from a to b f of x squared minus g of x squared, and then totally multiplied by dx. So be careful. I don't know, for some reason students sometimes make mistakes. They put a power 2 on top. That is wrong. Yes, be careful. If you calculate it step by step, you see that powers of 2 appear here and there, not here. So it is not f of x minus g of x totally squared. Okay? This is f of x squared minus g of x squared. Yes or no? Okay. So that is the formula that you need to remember if you are considering the volume of revolution for the area between two functions. The function above should come first, squared minus the function below second. Okay, let us for example do an example. Before doing this, let me ask you this first. How do you calculate this? Consider one arc of the sine function. Okay? And I want to rotate this about the x-axis. Okay, so what is the volume that I generate? Okay, I want to think about this for some time to find the exact volume. You need to understand these numbers yourself. This is the first arc of the sine function. I'm ignoring the other parts. And then I want to rotate this area about the x-axis. My goal is to find the volume. Yes? After doing that, I can give you another problem. So let us see how many of you can solve that. Okay? I pause recording. So the question for the people at home. So we have an arc of a sine function. We want to rotate it about the x-axis. And I want to find the volume. So I don't know if we can manage to show this one both for you and the people at home. Yeah, let us see how it goes. Yeah, so this is the way that I want you to visualize. It is good to visualize it at least once. So you see here, there is a curve. That's the sine function. But it is good to see it in this view because this is the x-axis, this is the y-axis, and this is y equals to sine function. But we have another axis So this, assume you can consider this as the ground level, and then we all want to see this one. And you see that the function is sine x. I want to rotate this about the x-axis from 0 to pi. And that's exactly our problem that I asked you to solve. But according to GeoGebra, I hope that you agree that you are supposed to calculate this integral. Yes? And this answer is approximate, of course. I expect you to get the exact answer. But that is approximate up to 2 decimal points. But then what happens is that this is the angle that I rotate. So if I wanted to see this, what happens at least. So if I start rotating that curve between 0 and pi about the x-axis, you see something like this will happen, yes? That is actually making a volume for you. Yeah, it seems like a sphere, but it is not a sphere, yes? Yeah, so if you go, now you can see it's not a sphere at all. So it deviates from a sphere completely clear. So if you want, we can see it from this point of view as well. So that is your curve, so we are rotating this about the x-axis, and then what happens is that we get this, yes? We want to find the volume of this object. So you see that if you have integrals, you can calculate the volume of very strange objects, yes? So for example, I don't know, there is no name for this one, by the way. We want to find the volume of that one. According to GeoGebra, the person who programmed that, so, but there are some default, commands you can use and play around if you want to explore something yourself. That is very good exercise. So, but I hope that you agree with me, you are supposed to calculate this integral. And then, how many of you got the exact answer? Because that is something that I have pointed several times. In the hard questions, they might ask you a primitive function for sine squared. And I told you the method to do that. 2 times at least in the course, okay? But probably you have forgotten how to do. So, but I want you to demonstrate, so I want to turn this off. I wanted you to see at least what happens if we do that. I think before closing it, it might be a good idea if we can visualize something, some other functions. So I don't know, for example, we can call it x to the power of 2, yes? And then let us make it, yeah, that's a good thing to see. Yes, let us go back here. So this is the just parabola. This is y equals to x squared, yes, the function. Of course, pi is not a very natural number here. Let me make it 2, for example. It's better. Okay, and then let us see what happens. Mainly, I want you to concentrate on rotation. You see, first of all, do you feel it is rotating about the x-axis? Yeah. So it's not good because the other part is not seen. So let me make it up to 1. Make it better. So yes, that is better now. So you can see all the shape now. So we go back. I cannot make it bigger because the people at home will not be able to see that then. Or might be we can, I don't know. Let me see how it goes. Yes. Okay, so now you see that is the, but now you have lost this. Okay, so let us make it more clear. So this is your function, your parabola, but I am concentrating on that part which is from 0 to 1. So I am here from 0 to 1. That portion of the graph is supposed to be rotated about the x-axis, and it will generate a volume for me. Yes, you see. It's similar to a cone, but definitely not a cone, because the sides of cone are straight lines, but the side of this cone is actually, if you say it cone, it is actually a parabola. So this is the shape that you get. Yes? Is that clear? So let us make it from, for example, 1 to 2. What will happen? I don't need to start from 1. This disappears because the volume becomes 0 now. But then let us see how it goes. Would you imagine that something like this will happen? Yes. Make it again 0. Okay, so, and then I start rotating. That part between 1 and 2 is being rotated now. This view is not good for seeing the rotation. So let us make this view, and then I increase this. I don't know if this is a better view or not, but the whole picture is cannot fit into this display. So something like that will happen, but of course this is not complete. Yes. But I mean, at least this is good to see this once happen. This is really happening, and we are calculating. Okay, so I will pause recording here, go back to solve that problem. I want you to, do you remember what was the number GeoGebra gave us? 4.93 for that number. Yes, let us see what happens. So now let me just skip this one. I don't know if they are recorded or not, because there are many things that I have to consider. I go back here. Okay, we are back now. So we actually want to calculate this one. So how should I do that? I should write the volume. First of all, this number, do you agree that this number is pi? Yes? Because this is the first time that the sine function intersects the x-axis. This is the first time, of course, but then after that pi comes in. So the integral becomes pi integral from 0 to pi, my function is squared. If I ask you to calculate the area, area is very simple. Because what you need to do, you need to put the function itself here. But do you remember how should I calculate a primitive function for sine squared? I told you, whenever the primitive function for sine squared or cosine squared is wanted, you need to remind yourself about the double angle formulas. Yes? So what was the double angle formula? For cosine 2x, we have two formulas. One of them is in terms of cosine, which when I move this to the other side, it becomes 1 plus cosine 2x. Then I divide everything by 2. It becomes cosine to the power of 2x. So I don't expect you to memorize this, but this is given in the formula sheet. You need to know the method. If I ask you to find the integral for cosine squared, you have to replace cosine squared with this formula. But you remember there is another formula in the formula sheet for cosine 2x, and that is 1 minus 2 sine squared. It is also given in the formula sheet. So let me move this to the other side. It becomes 2 sine squared x, and then move cosine to the other side, becomes minus 1 minus cosine 2x. I am looking for sine squared, so I divide everything by 2. It becomes 1 over 2 minus 1 over 2 cosine 2x. So you see, these are very nice and it's a little bit strange formulas, yes? So both cosine squared and sine squared can be expressed in terms of cosine of the double angle. And then for cosine, the only difference is that you have plus sign here, but for sine you have negative sign here. So this, I don't know, you need to remember, if sine squared and cosine squared appears for a primitive function, you need to remind yourself about the double angle formulas, and then this method will give you this, because these formulas in this form are not in the formula sheet, so you need to adapt, so you need to adjust it yourself. So this becomes pi integral from 0 to pi. Instead of sine squared, I use this formula now, which is 1 over 2 minus 1 over 2 cosine 2x, and then dx. But the rest is simple now. If I ask you what a primitive function, what is the primitive function for 1 over 2, it is just 1 over 2 times x. And hopefully you remember, a primitive function for cosine, it is in the table. It is 1 over 2 sine 2x, but that 1 over 2 will be multiplied here. It becomes minus 1 over 4 sine 2x. And then I have to calculate this integral from 0 to pi. I don't need to be worried about the lower limit, because if I plug 0, this vanishes, and this vanishes as well, sine of 0. So I don't need to be careful about this one. The only thing matters is this one. And that's also simple, because if I put pi here, it becomes pi over 2. But if I put pi here, sine of 2 pi is 0. So there is only one thing left for me, it's pi over 2. There is another pi here, so I multiply them. So this is the exact value. No, pi over 2 divided by 2, sorry. And if this is the exact value, And if you put this number in your calculator, according to GeoGebra, this answer should be approximately 4.93. You can check it. Yes, I think that's correct. Yes, because pi over 2 is around, is a little bit smaller than 10, and then divided by 2 becomes a little bit smaller than 5. So that's reasonable. But if you want, you can check it yourself. So that's the exact value. Yes? There is no time. I will continue this lesson one more session at least. I want to give you another problem here. So it might be that's a little bit harder. Okay, let me give you a simple example to see how to use this formula, and then write the harder one on the board, and then we solve it next time. Okay? So for the time being, forget about this problem. Let us make it a little bit simple. So what is so let me consider this. I have this function y equals to x squared, and then I have this horizontal line y equals to minus 1. No, that's not a good example. Let me sorry for that. So let me consider this function y equals to square root of x plus 1. Yes, this is 1. And then I consider this horizontal line y equals to 1. And then I take it from 0 to 4. Yes, I concentrate on this area. Now my question is that if I rotate that area about the x-axis, what will be the volume generated? Okay, so how should I solve this problem? This is my graph, y equals to square root of x plus 1. Do you remember when I drew the square root of x, it was like this? But this is a square root of x plus 1. So it is shifted 1 unit upward. Yes? And then y equals to 1. And then there is an area constraint between these curves and things. And then I want to rotate this area about the x-axis. Of course, you can imagine it will generate something hollow inside. Yes? But forget about the imagination. I want to find the exact value of that. I hope that you agree with me that I have to use this formula now, because there are two functions involved. One function is this function. The other function is a very simple function, but that's a function, y equals to 1. And this area is enclosed between these two functions. And I want to find the same area, the area rotated about the x-axis. So I hope that you agree with me that volume, in this case, is pi integral from 0 to 4, the function above squared. You see, f of x squared. The function above is the square root of x plus 1 squared minus the function below squared, and then dx. Yes, so I have to calculate the whole integral here. But the writing, the proper writing is important. Any questions regarding how should I write this? I'm just using this formula. The function above is this function. The function below is this function. So that is what I have written. And I have to calculate this. So what should I do? I write pi integral from 0 to 4. I square it using the squaring rule. The first one squared becomes x. 2 times the first one times the second one becomes 2 square root of x. The second one squared becomes 1 minus 1. So that's cancelled. Yes? Yes, is that understandable? Okay, now primitive functions are very standard here. But before doing that, I hope that you remember from even Math 3C that I have to write this as x to the power of 1/2. And then I can find primitive functions. So I have a pi involved here. A primitive function for x is 1/2 x squared. 2 is here. A primitive function for x to the power of 1/2. I have to add 1 unit and then divide it by that. So you can do it in your head. It becomes 2 over 3. X to the power of 3 over 2. And it goes from 0 to 4. So this is the number that I have to calculate. The good news is that I don't need to be worried about 0 because if I plug 0, both of them vanish. So I need to plug 4 here and there, and that will be my answer. So this becomes pi. I put 4 here to the power of 2, 16 divided by 2, 8. If I put 4 to the power of 3/2, it becomes 8 times this 16, 32 over 3. And then if I take the common denominator, it becomes 56 pi over 3 volume units. And the reason that I wrote it is because when I put 4 here, 4 to the power of 3 over 2 is 2 to the power of 2 to the power of 3 over 2. This becomes 2 to the power of 3, which becomes 8. So I did it in my head. When I put 4 here, it becomes 8 times 2, 16 times 2, 32. And then I have a 3. Yes? So this is good. But what I want you to write here, and you think about it, is that if I have this scenario, I have the sine function here, and then let me draw the cosine function. The cosine function reaches here to 0. Yes? Something like that. So you need to find these numbers yourself. And then let us concentrate on this part. Yeah, let us concentrate on this part. I want to rotate this part about the x-axis, and I want to find the volume generated by that. Yes? Okay, so this is the sine function. This one is the cosine function, the standard sine and cosine functions. And there is one area enclosed by the y-axis and these two curves. I rotate this about the x-axis again, and I want to find the volume of a revolution there. Yes? So next time I will start from solving this problem. I really want you to think about it, and then we continue a little bit more about this topic. Yes? Any questions here? Okay, thank you very much. We stop here.